we need to do what is called quantitative aspects of chemical change. So with quantitative aspects of chemical change. So it basically says, how best can we quantify the chemistry? How much of an object, how much of a substance can I be able to produce? So the word quantitative just basically says amount of substance. So we are interested in the amount of substance that we are going now to produce. But it means now, because of certain aspects of science, we are not going to be able to produce a certain amount because of now the certain aspects that now what relates to the chemical change. So this is just an overview of exactly what the topic entails. So we are interested in quantifying the substance, quantifying the amount of product that is produced, the amount that we have. But now one will ask, if I'm too quick, there's no problem. Just try now to follow with me. But I'm trying to be as slow as I can be. So what is it that quantifies or allows us to be in a position of knowing exactly what the chemical change is? What is quantitative aspects of chemical change? We have one key thing that is called the mole. So the mole concept is what governs the quantitative aspects of chemical change. So the mole, we will consider it in this case as now our base or our foundation of everything that we are going to do. So I will say now the mole concept, we consider it now as a base of quantitative aspects. Quantitative aspects. So because of this, resume sharing. Because of as a base of quantitative aspects, let me just write it here. Base of quantitative aspects. So as a base, it means it will be now a foundation for me. At the very same time, it will be what I need in order for me to fully explain everything that I am going to do. So the very first thing is we need to explain exactly what is a mole. So you might have seen these 4 bullets before, but now the 4 bullets are taken from the exam guideline. Why did I specifically choose to take this from the exam guideline? The reason for that is, remember, when we give definitions, it must be definitions as per the exam guideline. If we give the definitions, it must be as per CAPS document, such that now we have a universe, a way of understanding the science. So the science becomes easy if one from a specific location speaks now about the mole and one from a specific location speaks about the mole. Definitely we should be speaking about the same mole. That is the reason why the exam guideline is there. So you have textbooks, different textbooks. You were given, I think, 3 textbooks for physical science for this particular program. we will always refer to it, yes. But my biggest concern is, remember, we need now to have a standard approach. We need to have a way of answering the questions. So let's start by saying bullet number 1. It says, describe the mole as the SI unit for the amount of substance. Then it comes thereafter, says we need to define 1 mole. Somebody's writing on my screen. Tsepa, kindly stop it. This is my screen, it's not your screen. Basic rules, please. Because your tablets allows you also to write on top of the screen. So kindly don't write. I didn't have an opportunity to, or I didn't give you the rights to do so. Please. So if there's something that you'll need to write, I will give you a whiteboard and then you can be able to do that. Please. So don't disrupt me when I do something that I love. Thank you. So I was saying, we need now also to be in a position of defining what is a mole. That is the key thing. So first thing is, we should be able to define what is a mole. So a mole is defined as the amount of substance having the same number of particles as there are atoms in 12-gram carbon. Particles as there are in 12-gram carbon 12. So it says to me, if I am looking at carbon 12 as a reference, and when I look at the 12 gram of that particular carbon in the periodic table, I should be in a position of calculating the mole. But now, what will be the SI unit for this mole? So the SI unit is just mole. So the question should be, if the SI unit is mole, what is it that I can relate with this particular mole? There are different equations that each and every one of us need to know. The first equations, let's write here to say we have mole equations. And we are going to try and explain each one of them as we move. So for the mole equations, this is what is going to happen. The first one, it relates now number of moles with mass and molar mass. The second one relates the number of moles, which is N, with the number of particles over the Avogadro number. The other one relates now C is equals to N over V. The other one relates N, which is now N is equals to V over Vm. So all these equations are now very, very important equations to know. It's equations that allows us to calculate the number of moles. So we are going to go into deeper understanding of how best can we apply each one of them. In grade 10 is what we did, but now in grade 10 we used these equations And after using these equations, that was now the basic quantitative aspects of chemical change. But we still need this information from grade 10 in order for us to do what? In order for us to build into the grade 11 content. So the reason why I chose to start here is to remind you of things that we need in grade 10. And remember, this particular topic was chosen because it overlaps from now grade 10, 11, and 12. So hence we said, let's choose now a topic that allows us to be in a position of fully helping you to understand this particular concepts. So moving forward, we know that we have the SI unit, which is mole, and then we can denote now mole with a small n. So everywhere where I see a small n, definitely that should be now the number of moles. Moving forward, as before understanding the mole concept, if I am going to work with the mole, what is it that I exactly need? I'm going to write now this information here for equation number 1. So equation number 1 says N is equals to M over M. So now this here is just the mass that should be in grams, and this now should be the molar mass in grams per mole. So this is the key concept that now governs what we need to know. So remember, where do we get our number, the molar mass? We get the molar mass of each element from the periodic table. Hence, in the message that I sent, I said, now kindly have your periodic table in front of you, kindly have your calculator in front of you, as well as the book that was given, because we are going to relate on how best can we address this particular topic. Now that we understand that the mass must be in grams and then the molar mass must be in grams per mole, let's look at the question that I decided now to choose as a base, as a start for us now to fully understand. So at number 3, the question says, calculate the molar mass. So when we calculate the molar mass, what is it that we do? It's easy. We say the molar mass of the compound that is given is equals to how many hydrogen atoms do I have? I have 2 hydrogen atoms, each now bringing 1 1 gram per mole. Plus now, what is the molar mass of oxygen? The molar mass of oxygen, it's 16. So the answer here should be 18 grams per mole. So this is the basic way of calculating the molar mass. I want us to be in a position of ensuring that we are able to calculate the the molar mass, because once we are able to calculate the molar mass, the use of N is equals to M over the molar mass becomes now very easy, because this being the molar mass, it definitely assists in terms of using this particular equation. So my point is, we should be able to calculate the molar mass. So I have a timer. I'm going to do 3.2 as well. And then for question 4, we are going to do, I think it will be, let me highlight them. We are going to do 4.1, and we are also going to do 4.7. Only the two, just that we emphasize. Remember, I'm going to send you the PDF document of this particular lesson, and the video obviously will definitely be available. So I want us to be comfortable in terms of using this particular equation and calculating the molar mass. This is the foundation that we need to have. So for HCl, it will be the molar mass of HCl will just be now 1 plus. When I check into my periodic table, I have something like 35.5. So this will be 36.5 grams per mole. And remember, it is always important to write the correct SI unit. Once you omit the SI unit, we don't give you now a mark for that. So what is it that I'm going to do now? It's very easy. I'm going to give you a timer. Then in the chat group, you definitely share the number or the value that you got for 4.1 and 4.7. So that is now the section where we do it together. So for both of them, I'm going to give you exactly 5 minutes. So when the bell rings, it says you should now have shared your answers. So I'm going to give you even 5. It's a lot. Let me give you 4. We can even give you 5. Let's give you 5, and then you have your 5, and your time starts now. What is it that you do? You calculate now the molar mass for 4.1 and the molar mass for 4.7. I don't see your answers in the chat. Remember, we are calculating for 4.1 and 4.7. So I'm waiting for the answers. You can just give me a value, then the SI unit I will add. Just give me a value quickly. Thank you, guys. I'm no longer taking answers, so your time is over. I got few wrong answers. I was checking, especially for 4.1 and 4.7. So if your answer is not either 249.5 grams per mole for 4.1, and then for 4.7 I think we got something like 126. But now let's assist and help our fellow friends as to say how best can you go about this one. The common misconception here is this one, that when we work with multiplication, or the dot in this case, because I am given that is 4.1. Let me change my color to black. Copper sulfate that has now 5 waters there, which is a water of crystallization. So the most common mistake that majority of us will do is, when we see the dot, we'll think it says we must multiply, or it's not part of the calculation thereof. What it basically says is it must be now addition of everything, or each and every element that we have. So the easiest way of doing it is to say I want to calculate the molar mass of copper sulfate. So the first thing to do is, what is the molar mass of copper? I think from the periodic table is 63.5. And then what is the molar mass of sulfur? I think it's something like 32, because it's the values that I read now from the periodic table. Plus now how many oxygens? 4 oxygens, of which each contributes 16. Plus now 5 into 2 waters, 2 hydrogens, and then 1 oxygen. So all this in total, when I use my calculator, it should give me something like 245. But I want to verify that. Let me quickly get my calculator. So it's 63.5 plus now 32 plus now 4 multiplied by 16 plus 5 multiplied by the total there is 18. Remember, we calculated it first, so the answer here should be something like 249.5 grams per mole. That was now the basic one to do. Let's go for 4.7. It was now for COOH into bracket 2, and then it also had 2H2H2O. So basically we do the same approach, COOH 2 and then 2H2O. Then this will be something like carbon. It's 2 times now the molar mass of carbon is 12, plus now we can say 16 plus 16 is 32. So 2 multiplied by 32 plus now 2 multiplied by 1 plus 2 into 18. I don't want to waste time and calculate for each one of them. But what now do I need? I also need my calculator again. So what do I have? I have now 2 multiplied by 12 plus 2 into 32 plus now 2 multiplied by 1 plus 2 multiply by 18. So this will be 126 gram per mole. So if we are able to do such complex problems, then we will not have any problem in terms of ensuring that we are in the right direction when we calculate the molar mass. Let's move further on. This is basically the same slide. We now further extend it to say it's expected now from us. The question says calculate the number of moles of atoms in 96 grams of sulfur. So remember we said for us to calculate the number of moles, we need now to be able to be in such a situation. So in this instance, I am given the mass, and what is it that I am calculating for? I am calculating now for sulfur. So it will be easy such that I am able now to say my mass is in grams, so it is a check for me. I also know what is it that I'm working for. Then it's sulfur, then I can easily get the number of moles. So it will be N is equals to M over the molar mass, which is now 96. Look into my periodic table and get now the molar mass of sulfur, which is now 32. Take my calculator and punch in 96 divided by 32 is equals to 3. So the correct answer here is 3 mole. Very easy. But now the second question that follows is this question here that I want us to try and do in the next 2 minutes or so. It says calculate the mass of 0.5 of H2SO4. So I'm going to give you a timer again. So from the timer, this one I can give you 3 minutes or 4 minutes. Let me give you 4 minutes for this one, such that you calculate now the mass of 0.5 mole of H2SO4. Remember, send your answers in the chat because I will definitely see who's getting it right, who's definitely getting it wrong. Next time I'm going to ask now for pictures of exactly where did you do it. So your next 4 minutes starts right about now. Thank you guys for your answers. Your time is up. Let's discuss it in detail. I saw most of you got 49. Let's confirm if that is true. The approach here is I have the number of moles. So my quick data, 0.5 mole. The question wants me to calculate the mass. Then can I calculate the molar mass of H2SO4? Yes, H2SO4. I can, that will be 2 multiplied by 1 plus 32 plus now 4 multiplied by 16. Yes, 16. And then I will get my final answer. I need a calculator for that. It's 2 plus now 32 plus 4 multiplied by 16. I get 98 grams per mole. That is my molar mass. Then I can use my equation m over m, which is now mass 0.5 98, do the reciprocal, multiply by 98, multiply by 98, then these ones cancel, then my mass will be, calculator again, it will be 98 multiplied by 0.5 will give you 49 grams, 100%. So for this, it is usually 3 marks, 1 for the formula, and then 1 for the substitution of everything, and then your final answer. I believe this is clear. It doesn't want us to dwell much into it. It's straightforward and very clear. Nice question now. How many particles do the following contain? 2 moles of sodium and then 36 grams of water. It says now particles. I want us to go to the first slide here. So when you check the first slide, it says describe the Avogadro number as the number of particles, atoms, molecules, formula or formula units present now in 1 mole. The number of particles. So it basically says now, with me to be able or to be in a position of calculating the number of particles, atoms, molecules, I must now use the Avogadro number. So I am going to remove this and write now the relevant formula for this. It's N is equals to N over Na. The Na is the Avogadro constant, Avogadro number, and this number it's 6,023 multiplied by 10 to power 3 particles per mole. But this number I don't have to memorize and worry about, because now it will be given in the formula sheet. The only thing is the application of the Avogadro number. So with that, it says to me, then this N can be any number of particles. So this can be any number of particles, as well as number of atoms, molecules, and formula units. So when I am expected now to calculate the number of particles, I must relate that to the Avogadro number. When I am expected now to calculate the number of atoms, I must relate that to the Avogadro number. If I am expected now to have a number of molecules, it's clear that I can only relate this to the Avogadro number, provided that the number of moles should be given. That is very, very key. So I see there are people already trying to answer a few questions, but I didn't open for the answers. So I will wait and see if you are right or wrong. But all I wanted to emphasize is, remember, we are taking each equation and fully explain it such that we know what to look for when we are faced with the questions. So we are looking at this one. We are given the number of moles. I will definitely do the first one together with you. So I am given the number of moles, which is 2 mole, but I know that I have Na, which is 6,023 multiplied by 10 to power 23. Then I need to know the number of particles. So it's easy to do with this one. Remember N over Na. And I will forever emphasize, don't manipulate the formula. Write the formula as it appears in the formula sheet. So it says now I have 2, and then I have N, that is what I am looking for, 6,002 multiplied by 10 to power 23. Then I need my calculator for that. Then I will go and get my calculator. Let me move it a little bit here. So it's basically 2 multiplied by 6,002 exponent 23. Then my answer is 1 comma, I don't know where it went. Calculator again. So it's 2 multiplied by 6,002 exponent 23. So this will give me 1,204 multiplied by 10 to power 24. So this is now number of atoms. 1,204 multiplied by 10 to power 24 atoms. That is very, very important. So this is just N for sodium. So I'm going to give you just a minute to do 5.5.2. Let me open my timer again. Timer, just 2 minutes for you to finish this one. 5.2, ne guys. Thank you. Let's start, just 2 minutes. Send your answers in the chat so that I can see we are now in the same direction. Remember, we are at 5.2, guys, ne? 5.2, not 5.1, because 5.1, I used it as a source for explanation. So 5.5.2. Okay, thank you very much for your answers. Let's see if you did it now the right way. So the challenge here with this one, or the focus is, I am given the number of, I'm given the mass, which is in grams. So this is the mass. Now let me choose my pen. I'm given the mass that is now in grams. So the first thing to do is to ensure that I have the number of moles. So I must calculate basically the number of moles of water because of this. My pen doesn't want to write. I'm not sure what seems to be the problem, or maybe it's because of this. Let me just close the chats, and I will be able to write. So I'm given the mass. So remember I said the number of moles is the base of everything that we are going to do. So if I'm given the mass, I must convert the mass to the number of moles. So I'm going to say here I have now water. I know water is H2O. I have calculated the molar mass of water, which is 18 grams per mole. And I am given the mass of H2O, that is now 36 grams. So from N, I can be able to say M divided by M. This will be now 36 divided by 18. Then it will give me the number of moles. So let's take a calculator. Let's take a calculator. It's 36 divided by 18. It will give me 2. That is now 2 moles. But the question wanted now the number of atoms. So it means I must now relate the number of moles with the Avogadro number. So the Avogadro number is the only number that allows me to have now what? A link in terms of particles, molecules, and atoms. So I'm going to be able to say 2 multiplied by 6,02 multiply by 10 to power 23. Then I will need to be able to use my calculator again such that I get the correct answer. So let me see when I use my calculator, what is it that I will get. 2 multiplied by 6,02 multiply by 10 to power 23. So the answer is still 1,204 multiplied by 10 to power 24 from the information that is given. So 1,204 multiplied by 10 to power 24 atoms. I'm going to set up a timer again for the next 10 seconds to allow questions. If there are no questions, then we can proceed. Just 10 seconds for you to be able to ask something or raise your hand so that I can open up the floor. Just 10 seconds. So this will be 10 seconds. So I'm starting now. If there are no hands, then basically says definitely there are no questions, so I can easily move forward. So guys, this is what an online teaching is basically about. We need now to engage and follow up on each other. Very, very important. Let's go back to the first slide. The first slide, I think we addressed everything. I see there's a hand, but now the hand is from tab 8, so I don't know if who is tab 8, but I'm going to allow you to say something. I'm checking here who's tab 8. Tab 8, kindly say something. You know yourself, because I do not understand why don't I have you with your full names in this particular meeting. Tab 8. There's a lot of tab 8s, but the one with the hand up, kindly unmute yourself and say something. Tab 8. I see tab 8 doesn't want to say anything, guys. So I will pass. Okay, I see the mic is on. Tab 8, say something. Your hand is up. Okay. The question here is, aren't we supposed to multiply the answer with the number of atoms? Let me go to that particular slide. This is the slide. Yes. Yes, tab 8. What we do here, we did multiply. Remember, for the purpose of time, let me switch this one off. For the purpose of time, let me choose a different color for emphasis. This here, for us to get to our final answer. Hence, I took out my calculator if you are checking. So if I took out my calculator, basically what did I do? It's 2 for the number of moles. We multiply now by the Avogadro number, which is 6,023 exponent 23. Then we get our final answer. I want to show you something. It says here, 36 grams of water atoms. So we are not calculating for hydrogen specifically. We are not calculating for oxygen specifically. We are calculating now for water. If the question was specific to say now, let's calculate for hydrogen atoms. That is what I want to emphasize. Hydrogen atoms. Then we're in a position of now, if we get the number of moles and the number of atoms, we'll multiply the number of atoms with what? With the 2 of hydrogen, and oxygen will have the 1,2. So, but now the question is specific that we want now what? The atoms that are in water, not now the atoms or how do I say it? The number of hydrogen atoms in water. That is not what the question is saying. So if the question was specific to say we want the number of hydrogen atoms in water, then we will follow suit to say we must multiply now the number of atoms, that is 2, with now the final answer that we got. So, but now this, I must say, it's water atoms, if you are getting me right. So I'm going to pause a little bit for you to process that and maybe ask or open up your mic again. So I see there are 2 hands. Let me check who's asking the questions. Chat. So tab 8, if you are answered, then you can easily take down your hand. And then I will start with Muso Motau. You can open your mic and then ask your question.
So I think what tab 8 is trying to say is that in
Yes.
a single molecule, there are 3 atoms, right? So when we got that first answer, we basically got the number of molecules together, but they specifically the number of atoms. So we must multiply the number of molecules by the number of atoms that there are in a single molecule, sir.
Okay. I fully agree. Let me go to Ntabiseng. Thank you, Muso. Ntabiseng?
Sir, is it a necessity for us to specify whether we are calculating the number of atoms, even though the question already said atoms? And must we show that the calculations of the time at 5.2 we calculated the number of moles? Is it necessary? Do we have full marks on that one?
Okay, Ntabisen, you need to show each and everything that you do. Ne? The reason for that is, let's say this question was something like 5 marks. So the way the marks are going to be allocated, let's say it was 5 marks, and you decide now to calculate your moles somewhere else, and then you just come now and substitute the 2. It means you are going to lose a mark here for for the formula. You are also going to lose a mark here for what is this? Molar mass, the substitution of 18. Then you'll only get a mark for this one, and the final answer. So it means basically you are losing now the 2 marks up here because of you did not show all your steps. So it is important that everything that you do based on the mark allocation, you should indicate to the person who's going to mark your script. Remember, you are reporting to somebody who is knowledgeable about science, but now the marking criteria will need you now to show each and every single step, because we cannot give you 5 for the correct answer. We must give you 5 for the correct sequential process of getting to the final answer. Am I clear, Ntabisemi? Okay. Going back to your question, Muso, that's how it is. That's how it is. But I want you to understand, guys, the question here was not specific in terms of which atom are you calculating for. Water is a molecule. I fully agree. But now it means this here should be the number of molecules as well, not atoms. Let me correct it for the purpose of understanding. So basically this is water molecules here. Maybe it will make sense if we do that. Then to calculate the atoms, that is what you are going to do. Calculate now how many atoms are in water. So we have 3 atoms, so it will be 3 multiplied by the 1,204 multiplied by 10 to 24. So I'm getting you right now. So I believe it is clear. So hence now the discussion, hence we need to ensure that everything is done the right way. Jerry Thomas, your hand is up. Kindly switch off your video first, and then you can unmute yourself. Jerry, switch off your camera. Okay, Jerry doesn't want to say anything. So for the sake of time, I will move on so that we are able to follow suit. Tab 8, I think I addressed your issue. Then it means you are so right by saying this will be the molecules, not atoms. So definitely for us to get to the final answer, we must multiply the number of molecules with the number of atoms we have in the molecule. So that will be three atoms. So thank you very much, Ntabiseng. Tab 8 as well as Muso for the inputs. Thank you very much, guys. Let's move on then. So I was at this particular question. There's a chat. Let me check. Oh, thank you. Now we did everything in this first slide. That is where I was. So we defined the molar mass, we calculated the molar mass of the substance. So we are sure that everything now has been addressed fully. So if everything is addressed fully, then we are able to be in a position of the mole concept, we are done with that one. I'm taking questions from Manuku Makama. Manuku.
So, sir, in the Avogadro's number, it says that there are the Avogadro's number is the number of particles in one mole. Is there gonna be a case? Is there gonna be a case whereby there is more than a single mole?
Is there going to be a chance where we don't have a single mole?
No, sir. Is there gonna be a case whereby there is more than a single mole?
100%. Remember, what we do is we are quantifying everything that we are working with. Ne? So regardless of the number of moles you have, I will go back here. Okay, thank you. I will go back here. Ne? Regardless of the number of moles that you have. Basic rules, guys. Basic rules. Basic rules. My bed also. Okay. Manuku, the number of moles as per definition in one mole. So it does not mean if we have 0.5 mole, we cannot calculate the number of moles or the number of particles. Remember, we are quantifying. We are interested in the amount or the substance thereof. So what it basically says is the one mole is a general statement of the Avogadro number. But if we have 0.2, 0.5 mole, we can still know the amount of particles that are now being formed or the number of atoms that are in that particular substance that we are looking into. Remember, it's quantitative aspects of chemical change. So one mole is just a general statement. So if it's a general statement and the rule and the law, but now when I have 0.5, does it say I'm not going to have particles? No. It says just I will have particles, but for the certain number of moles that I have. So I hope that is clear, Manuku. And then there's another hand. Jerry Thomas, your hand has been up. How best can we assist you?
I say you have already answered my question.
Thank you very much, Jerry. Then lower your hand so that I can know that everyone is covered, sir.
Okay, sir.
Thank you very much, Your Excellency. And then Retabile is asking, does N represent number of particles, atoms, and formula units? Yes, Retabile, 100%. Hence, if you check here from the definition itself, it says describe Avogadro number as the number of particles in bracket, atoms, molecules, and formula units. So when we are asked to calculate for molecules, we'll still use the Avogadro number. If we are asked now to calculate for formula units, then we'll still be in a position of using the Avogadro number. 100%. So thank you very much. Let's move on. So I said now in this first slide, everything that we look into has been done. So what is the second concept that we need to look for? The second concept that we need to attend to is this one that is called molar volume of a gas. So it's clear, guys. It says gases. So the first thing that I need to emphasize is I can only apply when given a gas. So if I don't have a gas, then I cannot be able to apply what I am going to talk about in this particular slide. So it says we state the Avogadro number. 1 mole of any gas occupies the same volume as the temperature and pressure. Basically, it says the Avogadro number works at what we call the STP, which is now the standard temperature pressure. So some information relating to this information in a statement, I should be told that it is at STP. If it is not at STP, I cannot apply what I am going to write in the next few seconds. So the key word that I am looking for me to apply the molar volume of a gas, it means it must be in STP. So it says here 1 mole, let me clean it up. It says here 1 mole at STP. Let me use red. At STP, 1 mole of any gas occupies 22,4 dm cubed. Any gas. Let's emphasize that. So as long as it's a gas, regardless of its carbon dioxide, its oxygen, its ammonia gas, regardless of the type of gas, as long as it's a gas, it must occupy 22,4 decimeter cubed. But now at what temperature? At 0 degrees Celsius, which is now 273 kelvins, and then 1 atmospheric pressure. So what are basically this? These are the conditions for STP. The temperature must be at now 275 kelvins, and then pressure must be at 101,3 kilopascal. That is very, very key. So the molar volume of a gas is given now as 22,4 decimeter cube. There comes a challenge now. What is a challenge? The challenge is the volume here must be in decimeter cubed. So everything that I am given, I should be in a position of working with decimeter cubed. That is very, very key. What do I know? I know that 1 liter is equals to 1 decimeter cubed. If I have now centimeter cubed to dm cubed, what must I do? I must now divide with 1000. That is now the key important things that each and every one of us must we follow. So do we work with kPa or PA? Good. Nice question, Sibusiso. In this case, because we are only going to focus on the amount of substance produced, there is no way where we are going to work with pressure and temperature, because the new ATP of 2022 says that now everything that is related to pressure we are not going to focus into. But when we move now to grade 12 next year, we are going to work with pascals. So for now in grade 11, all we need to know is just 1 atmosphere, 1 ATM is equals to 101,3 kilopascal. Or it's something like 10,103 pascals, I think so, because you just multiply by 1,000. So Sibusiso, we don't necessarily need to have our pressure in kilopascal or in pascal. It's just a general statement of the conditions of STP. Maybe for the purpose of emphasis, let me remove this and write now conditions of STP. Conditions of STP. 1. Temperature. must be 273 kelvins, and then pressure must be 101.3 kilopascal. Very, very important. So once that it's addressed, we are in a position of clearly understanding. But now what is key here? It's N is equals to V over Vm. That is now another equation that we are focusing into. So it says to me, this V here is now just the volume, and Vm will be molar volume of a gas, molar volume of a gas, and this is 22.4 decimeter cubed per mole. So this is basically all that I need when I am given the molar volume of a gas. So at number 1, of which I want us to do it together, it says calculate the volume that 16 grams of oxygen occupies at STP. So it means now it's easy for me to say I want now V, that is the question, but I also need the number of moles for me to do that. I am given Vm, which is 22.4 decimeter cubed mole per mole. So what must I do first? I must now calculate the number of moles. So number of moles is M over M, which is equals to 16. The molar mass of oxygen is 32 because oxygen is O2, so it will be 16 plus 16, that is 32. Then for my calculator, it's 16 divided by 32. This will give me 0.5. So Ntabi saying 0.5 mole, it doesn't necessarily mean the Avogadro number now will not apply. So we are just going to quantify with the number of moles we have. So the gas that is going to be produced in this case, or the volume, will be Vm, which is equals to 0.5 V, and then multiply by 22.4. Then take the calculator again. This is just now 0.5 multiply by 22.4, which is equals to 11.2. So V is equals to 11.2 decimeter cubed. Very, very easy to do. So for number 2, I'm going to give you 2 minutes so that you can finish it off. So let me first maybe check the question. Okay, open it up. Mini tools, timer. I'm just giving you 2 minutes, guys, for this one. It's easy for us to do. So 2 minutes for that. Let me put it somewhere here. I'm not getting your answers, guys. Send your answers. Send your answers. There's only 5 people now. Thank you very much. You're no longer accepting answers. So I see most of you got 12,14 grams. Let's verify if that is true. The question says now, what mass of ammonia gas must occupy a volume of 16 grams at STP? Thank you very much, but we are no longer taking answers. That's the reason why we have a timer, so that everything is controlled. Let's see now, where do we start? The easiest way is, I am given ammonia in weights. So the first thing is, I need to know the formula of ammonia, which is now NH3. How is this going to assist me? Remember, everything, the base is the number of moles. What else am I given? I am given the volume at STP. Is the volume in decimeter cubed? No, but now from this here, I know that I still have 16 decimeter cubed. So what do I need? I need first to get the number of moles. Is there a relevant formula that I can use? Yes, I can easily say the number of moles is equals to V over Vm. Then I have 16 divided by 22,4, which will be now from the calculator. It's 16 divided by 22,4. It's giving me something like 0,714. 0,714 mole. Then I have the number of moles. Can I now relate the number of moles with mass? Yes, I can. So I have 0,714, which is equals to mass over now what? The molar mass of ammonia. So what do I know? Nitrogen is 14 plus 3 multiplied by 1, so that is basically 17. So I am just going to use my calculator again. I have 0,714 multiplied by 17 is equals to 12,14. So my mass is 12,1414 grams. Very easy and very happy. So to the person who asked that, is it not possible or is it needed for us to show all the steps? Yes, it's needed. If I was now sitting somewhere and trying to mark you correctly, I will give you 1 for the correct formula, 1 now for this particular substitution. I will also give you 1 for the formula there, and then 1 for the answer and the calculation. Then you will be able to get your full 5 marks. So if that part is not there, definitely you will only get 3 out of the 5, and we don't want that. Now, thank you very much, guys. Let me give you 10 seconds to raise your hands, especially when we talk now molar volume of a gas. Let me open my timer, just 10 seconds. If there's anyone who wants to ask or say something, just 10 seconds. Go. Okay, I saw hands from Moho. Moho, you can switch on your mic and then ask your question.
Sir, I was asking for clarity on the conversion from liters to cubic decimeters because I think I didn't quite get that, so it affected my calculations.
Okay, it's standard, ne? You must just know that 1 liter it's 1 decimeter cubed.
Okay.
Yes, it's a standard procedure. As much as we know that 1 meter is equals to 100 centimeters, it's basically standard.
Okay, thank you,
Yes.
sir.
So all you need to do is maybe when you sit down, kindly check now what is going to happen if you move from centimeter cubed to decimeter cubed. If you move now from meter cubed to decimeter cubed, what is it that is going to happen? Because in most cases, we'll only be working with decimeter cubed.
Okay, thank you, sir.
Thank you very much, Moho. Ntabiseng, in that order.
Sir, I'm asking if would it still be correct if when I calculated my number of moles, I wrote it in a fraction form and not in a decimal form?
It doesn't really matter, ma'am, because what we do is you'll still get the same answer regardless, but we are going to confirm if what we have in a fraction form, it's exactly the same as we have in a decimal form. If they do correspond, then there's no need to penalize you for the final answer. But remember, the rules of the exam, the first one says, leave your answer or round off your answer to 2 decimal places. Ne? So if you do not have the decimals thereof, so it is making our life difficult as the examiners, as the people who are setting these particular papers. So best way is to give it in a decimal form and round off now to the 2 decimal places.
Okay, thank you, sir.
Thank you very much, Ntabise. Manuku. Manuku?
Sir.
Yes,
so here,
ma'am.
where do we use the 273K and the 101.3 kilopascals? Where do we use them?
Okay, thank you very much. Remember, it's just conditions of STP. Ne? So the previous syllabus before COVID, we were going to use this when we were calculating at which temperature does a gas becomes a liquid, at which pressure. So that topic that wants us to deal with 273 and 101.3 kilopascal has been withdrawn due to COVID. But now the content of molar gas volume must still be there because we will still need to talk of STP. If somewhere, maybe I must write it down, you came across, let me use a darker pen. You came across this equation PV is equals to nRT somewhere, ne? So this is where we are going to use that. The P will be for pressure, the T for the temperature, the N now for the number of moles, the R for gas constant, and then the V for the volume. But this has been now taken out. This is no longer relevant after caps, but the conditions of STP still do apply. Happy Manukume. Thank you. Tenolo, I see your question is, what if our gas is not STP? Are we still going to use 22,4? No, Tenolo. If our gas is not at STP, then we are not going to use 22,4. 22,4 is only for STP. So if it's not at STP, it means a specific molar volume of a gas will be given. So for instance, if this was not there, let me change the pen now. if this was not there, then they will have told us that at or the molar volume is equals to 20,3. Then we are going to use that 20,3. So it is only applicable if we have the information that we are working with a gas that is now at STP. At times, they will not tell you it's at STP. They will just say, now what is the mass of ammonia gas, gas volume or gas occupies at a volume of 16 liters at the pressure of 1,13 kilopascal and the temperature of 273 kilopascal. You see, it's the conditions of STP. So because we are told, because of they are not necessarily saying at STP, but they are telling us the conditions, then it means we know it's STP. But if they just say to us, okay, fine, it's not at STP, then they must give us something to work with. So they will say the molar volume of a gas is 20, it's 19, depending on the information that is given on the formula, not formula sheet, the question paper or the stem of the question. So Tenolo, if that was what is you are going to ask, thank you very much. Then you can lower your hand so that we finish off and move on to the next section. Thank you very much, guys, for all your inputs. The last one is concentration. The last one is concentration. So it says here, define concentration. Let me change a pen to red. Define concentration as the amount of solute per liter of a solution. So this is the equation that we spoke about when we started. So it basically says C is equals to N over V. So the V also must be in decimeter cubed. Very, very important. And then this must be just in mole. And then the SI unit will be mole per decimeter cubed. That's how simple it gets. That's how easy we are in a position of answering the questions thereof. So I will request you to do number one for us. That will be the last one, and then I will give you now what is going to happen moving forward. So this one, let's see the level of difficulty. This one just needs 2 minutes. So I'm just going to give you 2 minutes. It's not even 2 minutes, it's even, let me just give you a minute. A minute and 30 seconds, maybe. Then I'm going to check your answers in the chat room. So let's go. Thank you very much, guys. We are no longer accepting answers. So its most common answer is 0.8. And let's confirm if that is true. Key thing, calculate the concentration of the solution that contains 0.2 mole. The number of moles is given of copper sulfate in 250 centimeter cubed of water. So it's key. We did say that our volume must be in decimeter cubed. So I'm just going to say V is equals to 250 centimeter cubed, which is equals to, remember we must now divide by 1,000. So let me check here, calculator. It's 250 divided by 1,000. Then we have something like 0.25. So 0.25 decimeter cubed. The number of moles is given at 0.2 mole. Then the question wants us to calculate the concentration. So C is equals to N over V, which is just 0.2 divided now by 0.25, which is equals to mole per decimeter cubed. So I need my calculator for that. It's just 0.2 divided by 0.25 is equals to 0.8 mole per decimeter cubed. So